In this video, we will see the various examples of how to draw the DAG, that is directed acyclic graph. So first example, it is given here. It is within the parenthesis a plus b multiplied by a plus b plus c. So as the property of DAG, what we have to do, first of all, identify which are the common expressions in the given example. So the very first step I will write here. Very first step is what? Generate the three address codes. So we have to generate the three address codes first of all. So let's take one by one and solve this expression. It involves the operator like plus, multiplication and plus only. So it will be left to right associative expression, and we need to consider the precedence as well. So as you can see, there is the expression 1 and expression 2, and both the expressions are multiplied together. So by considering all these facts, we will generate the three address code first of all. So let us say a plus b is there, so I will create a temporary t1 equal to a plus b. So I have created first temp variable t1 and assigned a plus b expression to it. Let us go to the next part. In the next part, as you can observe here, the expression consists of a plus b plus c. So both plus are there and both plus are like it is left to right associative. So leftmost plus is having higher precedence than the rightmost plus. So what we have to do, we will first of all compute this result. So a plus b is already denoted here. So what we will do, we will make use of this. So t1, so this will be replaced by t1 plus remaining part, so t1 plus c, and I will assign this to next temp variable, that is t2. So in this way, this parenthesis will get resolved. Now next I will create a third temp variable, let's say t3, and to the t3 I will assign the both parts. Now this part is nothing but t1, and this entire part is nothing but now t2. So I will create a t3 as a new temp variable and assign t1 multiplied by t2. So this is how the three address code is created for the given expression. Now in the second step, we will draw the actual graph. So how we can draw the graph? Let us start with the given operands. So I will create the t1 address code first of all. So I will simply put a and b. So a and b are nothing but the plus, and to that I will call as a t1. So it will be, let us say, t1. Now so t1 graph is created. For t2 I will be adding t1 with c. So let us say c is here, and now add this t1 with c. So this way I have created t2, and next I have to multiply t1 and t2. So t1 and t2 has to be multiplied. So multiply t1 and t2. I will connect this t1 and t2, and I will create the t3. So in this way, the DAG for the given example can be created. Here what I have ensured, that a plus b part is like it is repeated, so it is not taken again and again. Only one time it is taken and it is reused. So this is the advantage of using DAG, and for the given example, three address code is created and its corresponding DAG is represented. Now we will see the second example where we are finding the directed acyclic graph. So the example is given to you. Now it consists a divided by b plus a divided by b into c star d. So how we can solve this example? Just see. First of all, we will create the three address code. So I will write the step 1 where we will generate some three address codes. So let us see what are the different operators used in this particular expression. So it uses the operators a divided by b, then a again a divided by b, both are added, and then the multiplication. So let us consider left to right associativity as well as the precedence of the operator. Now generate the three address code. So first of all, we will generate the three address code going from left to right. So t1 will be created, which will denote a or b, this particular operation. Now let us go to the next part. Here in this expression, so first part will be added with this entire part because multiplication has higher precedence. So what we will do, we will create the uh, TSE for this particular entire part, entire expression. So I will create a new temp variable which will denote C into D part. So this will be denoted by the T2. As we all know, this is nothing but your T1. This is similar to T1, so this is nothing but the T1. So I have created T2. Next, now I will combine this particular expression which is not presented in the parenthesis, but this will be the combined part. So I will create a new variable T3 equal to, just multiply that T1 into T2. So in this way T3 will be created. So this entire portion will now be called as T3. And the last code that is required, we will see. Next is T4 is equal to, what we have to do, we have to add T1 with T3. So it will be T1 plus T3. So in this way we have created the TSE for given expression. Now we will draw the DAG for the given expression based on the generated TSE. So first of all, I'll represent A and B, and both are combined with divide operation. So this will be nothing but a T1 address code. So I will mark as a T1. Now next C star D. So I will generate C D, and both are connected with star. So to this I will mark as T2. Next code is T1 into T2. So T1 into T2. So just multiply both T1 into T2 and create T3 here, and at last we have T1 plus T3. So T1 plus T3, I will just create a plus and I will add T1 with T3, and this will be called as T4. So this is nothing but the DAG for given expression. Now see the third example where we are going to find out the TAG. So this is the example. This is very lengthy expression. So two parentheses we have to add together. So we will go step by step. We will resolve first parenthesized expression, that is this one, and after that we will be evaluating the second expression. So let us start creating the three address code for the given expression. So as you can see, for this particular expression we will be generating three address codes like, so x plus y and x minus y are the common expression in the given are the common sub expressions, we can say, in the given expression. So what we will be doing, I will be creating, let's say, T1 equal to x plus y and T2 equal to x minus y as my step number 1, where I am generating the TSE. So T1 and T2 are temp variables created for sub expressions x plus y and x minus y. So this is my first step I have created. Now I will go for solving the brackets. So here you can observe, for this particular entire expression, two sub expressions are there, number 1 and number 2. These are called a sub expression. So these are separated by subtraction sign. Okay, so but this expression will be evaluated first since it has the multiplication, so it takes the higher precedence. So what we will do, we will simply solve this particular bracket. So for that reason I am creating a new temp, let's say T3, which will be computing the multiplication of that is T1 for this x plus y multiplied by T2 for this x minus y. So T3 will be created and it will be T1 into T2. So this part is over, this part is over. Now we will combine this two sub expression into one sub expression. So next will be T4 equal to, this is T1 first part, T1 minus T3, T1 minus T3. So in this way the entire this expression will be represented by T4. Now we will focus on the second expression. So in the second expression we are having simply x plus y, that is T1, multiplied by x minus y, that is T2. So what we will be having, T5 equal to T1 multiplied by T2. It is T1 multiplied by T2, but T1 multiplied by T2 is already represented by T3. So we have the code ready for this particular thing. X plus y multiplied by x minus y. So we have code ready for it. So what we will be doing, T3 represents the T1 multiplied by T2. This T3 represents T1 multiplied by T2. So what we will do, we will simply add the first part, which is represented by T4, plus the second part, which is entirely represented by T3. So for T5 I am simply using T4 and plus, that is plus T3. So this is how the TAC is computed for the given expression. Next we will see how to draw the DAG. Now we will draw the DAG for this created 3 address code. So just represent x plus y. So x and y are there, and this x and y are added together. So this is nothing but our T1 part. This is nothing but T1 part where x plus y is added. So T1 I have created. Now x minus y. So if I write x, y and minus, okay, so this will violate the principle of DAG, because the reusability is the main concern. For that reason we are using the DAG. So here the operands are not reused. So instead of repeating this, recomputing this, I'll simply erase this, and what we can do, this x and y will be reused. So x and y are used here. So in this way I have represented, or I can represent the T2 address code. So x plus y is T1. So just keep the proper lining between both the T1 and T2. So x plus y is T1 and x minus y is T2. Next is T3 equal to T1 multiplied by T2. So create the T3. So T1 multiplied by T2, it is nothing but my T3. So I have created T3 over here. Next what I have T4 equal to T1 minus T3. So T4 equal to T1 minus T3. So T4 I have created, which is T1 minus T3. So T4 is created, and at last I have T5 as T4 plus T3. So T4 plus T3 I can create like this, and I will name it as a T5. So in this way the DAG will be created for this expression. Just look at the expression and its corresponding 3 address code as well as DAG for it. Now let us see the next example to find out the DAG. So example is a plus a multiplied by b minus c plus b minus c into d. So step 1, as I said, step 1 will be, we will find 3 address codes. So let us start with it. So if you consider the precedence of operators, then multiplication is having higher precedence over the plus. Similarly here multiplication will have the higher precedence. So we will find out our first temp variable for this particular expression, that is b minus c. Now we will compute for this entire sub expression a into b minus c. So it will be T2 and a multiplied by T1. So this particular sub expression is represented with using T1. Now next we will focus on this part, the second part. So here T3 equal to b minus c is already there as a T1. So simply just multiply that T1 with d. So T1 is multiplied by d, that is nothing but my next temp variable. Now here this part is over, this part is over, this part is entirely called as T3 and this part is entirely called as T2. So now what we will do, we will simply add this a into T2. So T4 equal to a plus T2, and at last this entire T4 part we will add with T3. So T5 equal to T4 plus T3. So in this way we have created the 3 address code for this example. Next we will see how to draw the DAG. Now just put all these 3 address codes into the directed acyclic graph. Just see how we can do this. Simply start with the T1, that is B and C, both are connected by minus operator. So you can name this particular node as T1. Next is A into T1. So A into T1, we will create the T2 basically. So this T1 and A we will combine. So I will write A over here and I will combine this with multiplication. So multiplication is there and it will be named as T2. Next we will be having T3 as T1 into D. So T1 into D we have to create. So T1, this part T1 multiplied by D I am going to create. So T1 multiplied by D, and this particular node, this multiplication node, it will be called as T3. So just name it as a T3. Next we will be having T4 equal to A into T2. So T4 equal to A into T2. So A into T2 will form the T4. So A and this T2 plus will be the operator. It will form the T4. So it will be called as T4. And next we will be having T5 as T4 plus T3. So T4 and T3 will be added together and this node will be called as T5. So for the given example we created the 3 address code as well as we have constructed the DAG. So this is the solution. Thank you. The next example expression is given like this. So here you can observe multiple parentheses are there. So we have first expression, similar to that second expression, 2 sub expressions are added together. Here also 2 different sub expressions added together, and in the example you can observe all the sub expressions are similar to each other. That means this repetition we have to avoid when we draw the DAG. So how we can draw the DAG for this? It is very simple. So first thing is what you have to draw the A, and both are nothing but the plus. So first of all I have represented both A and A with a plus. So this A plus A is represented as with the help of this particular part of the DAG. So this portion I have represented here. Now it is added with the second sub expression which is similar to that. So it is represented as, simply draw an edge and do like this. So by making this, what we have conveying, this expression is again added with the same expression. This is the meaning of this. So this entire thing is represented with this particular expression. This entire part of the DAG represents the left side of the expression. Now for the right hand side, here also you can see A plus A is there and A plus A is there. So instead of resolving individual brackets, you can observe the first sub expression is similar to the second sub expression. So for this we have already drawn the DAG. So this DAG will be applicable for this particular right hand side sub expression. So what changes we require? We are simply conveying that this part is added to itself again. So this is represented as, simply draw one more edge, it is addition, and this part, this entire part is again added with itself. So by doing this we have added the A plus A plus A plus A with itself. So this is the DAG for a given expression. Now see the next example. Now here total 6 statements are given to you, and for these 6 statements DAG is asked to draw. So let us start with the step 1. So in a step 1, what we will do, we will write or construct the part for B star C. So B star C will be there, and I will denote this particular part as A. Now go to the next step. In the next step, choose the statement number 2. So in the statement number 2, D equal to B is given. So how we can write this? Draw the same B and C. Now here D equal to B, so simply append D at the B position. Rest of the part will remain same. Now take the third statement. It is step number 3. For the third statement, E equal to D star C. Now you can observe in the earlier step D star C is already present, so no need to redraw it again. So simply what we can do, D and B are here, so this is D star C operation is there, and I will call this D star C operation as E, so E will be appended there. Now in the step 4, take the fourth statement. Fourth statement is B equal to E, so B equal to E is there. Now just observe here in the earlier step B is here and E is here, so we have to move this B to this particular position. Basically such statements are not needed, and for that reason the DAG has to be optimized. This is called as code optimization process, because B is denoting the E, as well as here if you observe D equal to B, so and after that D star C is there. Actually if B star C is already present, there is no need to have introducing the new variable D over here, which is again representing the same result, because in this expression if I put D as a B, I will get a result as B star C, and already I have stored B star C into the A. So this is called as a dead node, dead code. Basically when we have E, B equal to E, D equal to B, this kind of code is called as dead code, where this is really unnecessary. So the code optimization actually handles this part. So coming to the step 4, for B equal to E, what we will do, we will shift this B over here, so it will become like this. D and C will be star, and the top values will be A, E and B. So in this way it will be denoted. Now in the step 5, so in the step 5, consider the fifth statement. What is fifth statement? It is nothing but F equal to B plus C. So F has to be introduced. F is equal to B plus C. So what is B? B is over here. B plus C we have to perform. So I will simply draw like this: star A, E, B. So I will perform addition of this B with C. It will be D, it will be C, and both are added together, and the new node, it will be called as F. So it will be F node. So it is represented, and let us consider the sixth statement. So I'll draw the step 6 over here. Step 6. So G equal to F plus D. So consider the earlier diagram. So F is like this. F is here. F is denoted by star, that is A, E and B, and it is actually the C and D. This is F, and F is added with D. So F plus D we have to represent F, and D has to be added, and now this will be called as G. So in this way we have created the DAG for given expression. All steps are visible to you, so each and every statement is represented here. As I said, there is a dead code as well, D equal to B and B equal to E, which are producing the same result again and again. So we have to optimize it. So we will see how to optimize that particular dead code. So for this given DAG here, as we discussed, this B equal to E, that particular statement is really not necessary, and this generates the dead code. So we will be removing this B equal to E. Because of that, what will happen, the statement E equal to D star C, it is also not required, because already D is equate to the B, and this indirectly producing the B star C, and which is already present in the A. So we will remove this particular B equal to U statement, and because of that, because of this statement is also got removed. So the improved or the optimized DAG would consist the statement like this: A equal to B star C, then we have D equal to B. Next the remaining two statements will be omitted, and the statement will be directly taken as F equal to B plus C and G equal to F plus D. So what you can do, you can write the optimized DAG for by considering these four statements. So just make the changes in the entire DAG. Consider these four statements now, and you can draw the DAG for these statements. So drawing the DAG for these four statements is pretty easy. You can refer the earlier steps, and you can like connect the nodes with each other. So consider the next example where the block of statement is given to you. It contains the statement which will be executed in a sequence, and for this you have to draw the DAG. So it looks like very lengthy one, but if we follow the given steps and the rules to draw this DAG, it will be easier for us. In the given block, if required, we will perform some necessary code optimization. So let us start with the drawing of DAG. So consider the first instruction, that is S1 equal to 4 into I. So for that, simply I am drawing the DAG construct. So it will be 4 into I. So for the 4 into I have drawn this particular construct. Now next I have the S2 part, that is address of A minus 4. So this 4 is already we have to simply create this address of A node. So what I'll do, I'll create address of A node. So just create here address of A node and address of A minus 4. So address of A minus 4 I am creating, and this will be called as S2. This will be called as S2. First we have created 4 into I, so it is nothing but here S1. So S1 and S2 are over. Now S3. S3 is nothing but S2 of S1. So S3 is nothing but S2 of S1. So how we can represent this? So just create S2 and S1 connected together, and the notation that I can use to denote this S2 of S1 is, it will be like this. S2 of S1 will be created like this. So for S2 of S1 I am creating notation like equal to and the square bracket. So in this notation I am going to store the S3 part. So S3 is created like this. So S3 will be S2 of S1. Now S4 is 4 into I. So already we have 4 into I, so we will be appending S4 with the same node, that is similar to S1. S5 is address of B minus 4. So before going to S5, just understand there is simply not required this S4 part, because we have already 4 into I operation in place, and again S4 is created. So during the code optimization, such redundant entries will be removed. So this is actually the application of DAG. It helps us to avoid the recomputation. So now we will switch to S5. S5 is address of B minus 4. So address of B minus 4 we will draw. So for the S5 I will be using address of B minus 4. So 4 is here. I will create the minus, and I will be creating address of B. So it will be address of B. So this way I have created S5. I will name this S5 now. Now next I have S6 as S5 of 4. So we will be creating S6 as S5 of 4. So for that, just understand where is S5 and where is S4. So S4 is here and S5 is here. So for that we will create the S6. So it will be again equal to, and because we are creating S5 of 4. So I have joined S4 and S5. This node will be called as S6. So S6 will be S5 of S4. Then S7 will be S3 into S6. So S7 will be S3 into S6. So for that, what we will do, see here, S7 will be S3 into S6. So just connect S3 and S6. S3 and S6 are connect. They are multiplied together, and we will be creating S7 out of it. So for S7, that is S3 into S6, we have created node like this. If you are able to see, S7 is nothing but S3 into S6. So we have created S3 into S6 as S7 node. Next node is asset as production. That is not production, it is product. Asset equal to product plus S7. So we have to create product as a new node, and we have to add S7 into it. So S7 is there, we will be adding this S7. So add this S7 with a new node, let's say prod, and this will be called as asset. So asset will be addition of product plus S7, product plus S7. Now this asset is again assigned to prod. So asset is again assigned to prod. So here we will not be creating a new node. Instead, asset is assigned to prod, so it will be called as prod. Again, the redundancy is occurred. So during the code optimization, we will remove this redundancy. So now S9 will be I plus 1. So S9 will be I plus 1, I plus and 1 I am creating here, and it will be called as S9. So S9 equal to I plus 1 is there, and next statement is I equal to S9. Again S9 is assigned to I. Again this is unnecessary. So this I plus 1 will be called as I. Already we have node I, and newly I will be denoted or modified. So it is unnecessary. During optimization we have to remove this. And lastly we have, if I is less than or equal to 20, then go to L10. So it is less than or equal to value will be 20. So value is 20. If it is so, it will be called as L10. So in this way, all the given statements are denoted with the help of DAG. This is the final DAG. Take a look at it. This is address, basically address of B. So this is the final DAG we have drawn. Now if you look at this particular given block of code here, the some of the productions are some of the sub expressions are repeated. Just consider the S1 and S4. So here S1 and S4 are similar to each other. So we have to eliminate these expressions because both are producing the same result. So we have to eliminate these S1 and S4. So the S1 and S4 we have to eliminate during the code optimization. Also, if you focus on asset, so what asset is doing? Asset is creating production plus S7 and production equal to product equal to asset. So this can be improved, like if we want to create the product, so it can be created as product plus S7. That means this product plus S7 already created, we will be assigning it to again asset, and asset is assigned to product. So this can be done like product equal to product plus S7. So same I have written here, it could be created like product equal to product plus 7. So just look at the asset and asset statement, product equal to S7, and again assign asset to product. So product equal to product plus S7, that will do. So during the optimization we can add this statement and we can remove these two lines, that is this line and this line can be removed from the code optimization. Similarly, for the S9 equal to I plus 1 and I equal to S9, for this what we can write, instead of using this S9 again and again, these two S9 equal to I plus 1 and assign S9 to I, we can simply make like I equal to I plus 1. So just look at here, I equal to I plus 1. Look at the S9 statement, I equal to 1 and assign S9 to I. So it can be created like I equal to I plus 1. And as I said initially, S1 and S4, eliminate S4 statement completely because it is totally unnecessary. So when we remove S4, S8 and S9 statement, I repeat, when we remove S4, S8, S9 statement, the optimized code block will be created and it will simply look like this. So this is the optimized code where S4 is not there, S8 is not there and S9 is not there. So instead of S8 we have this particular expression, and instead of S9 this particular expression. So this is just for the S8 and this I plus 1, it is for the S9. So by considering this, I have written the optimized code, and for now this code you can draw the DAG, that will be full and finalized DAG. So this is how we can draw the DAG. Thank you.